Welcome to wpi.edu/listen, your go-to audio news and podcasts for all things Worcester Polytechnic Institute. After you've listened in, check out our other episodes and dive deep into the exciting news stories shaping the WPI community. Wednesday, June 4, 2025. From rubble to rockets, turning scrap metal into essential equipment. WPI researchers aim to revolutionize on-site additive manufacturing by combining materials, science, artificial intelligence, and 3D printing. Worcester Polytechnic Institute, WPI, has been awarded $6.3 million for a groundbreaking initiative that could transform additive manufacturing by enabling the rapid production of high-quality components from scrap metal. This innovative approach to additive manufacturing, funded by the Defense Advanced Research Projects Agency, DARPA, aims to ensure that essential components can be produced even in the most resource-limited environments, including where access to traditional supply chains is limited, such as battlefields or remote search and rescue locations. The initiative, called Rubble to Rockets, applies a machine learning approach to identify materials, like scrap metal and mixed alloys, and understand how they react and bond together before being melted, mixed, and 3D printed to form new parts that are strong and reliable. Traditional 3D printing methods require carefully controlled materials and repeated testing and adjusting, something that's not always possible in real-world settings. This work is crucial as it allows us to build high-quality components from unknown source materials with new confidence, said Associate Professor Danielle Coate, Harold L. Jurist, 61, and Heather E. Jurist, Dean's Professor of Mechanical and Materials Engineering, and the lead researcher on the project. Our goal is not just to build a single solution but to create a framework that guides future innovations. By improving our predictions and understanding of material performance, we can pave the way for new advancements in additive manufacturing from diverse and unpredictable sources. The team will use artificial intelligence, AI, technology developed by Citrine Informatics to predict material behavior at various compositions, optimizing and automating the characterization processes. By streamlining the procedure, the product can be manufactured at a rapid pace, but not at the expense of durability and strength. Researchers will design a proof-of-concept sounding rocket to test the structural integrity of mixed metals and measure performance and reliability.